For section 1.6, we're talking about angle relationships. Our central question, how can you use angle pairs to find angle measurements? Section 1.6, angle pair relationships. How can you use angle pairs to find angle measurements? Topics and objectives. We want to know what vertical angles are. We want to identify linear pairs. We want to be able to solve problems with complementary and supplementary angles. And we want to be able to define adjacent angles. Okay, sometimes you could call it angle 1, but for convenience, for now, that's good. Once we add additional, is it angle 1? Is it angle 1 plus 2? Is it angle 1 plus 3? Is it all of those? When we're talking about vertical angles, we are using two intersecting lines. The angles across from each other, the angles that form two V's, are called vertical angles. 3 and 4 are vertical angles. Okay, two angles are vertical angles if their sides form two pairs of opposite rays. Remember your definition of opposite rays. So, angles 1 and 2 are a pair of vertical angles. Angles 3 and 4 are vertical angles. Vertical angles are always congruent. That's our vertical angles property. A linear pair. It is a pair, two angles that form a line. It's formed by two opposite rays and their non-common side. Angles 1 and 2 are a linear pair. The sum of a linear pair is 180 degrees. Are 1 and 2 a linear pair? Does their non-common side form a line? Why, yes, they are. Are 4 and 5 a linear pair? Does their non-common side form a line? No, they are not. How about 3 and 5? Are they vertical angles? Are they formed by two lines, two pairs of opposite rays? No, they are not. How about angles 1 and 3? Vertical angles formed by two pairs of opposite rays? Yes, they are. Okay, find the measures of the three angles. Angle 1 and the 50 are vertical angles. We know vertical angles are congruent, so we know angle 1 is 150. Angle 1 and angle 2 are a linear pair. We know the sum of a linear pair is 180, so angle 2 is 130. Angle 2 and angle 3 are vertical angles, and thus congruent, so angle 3 is 130. Angle AEB and angle BEC are a linear pair. Therefore, we know that the measure of those two equals 180. Solving for that, set it equal to 180. Solving for x, we get x is 16. 16 is not the answer of either of those measures. 16 is the x that gets inserted into those. Inserting it in, we get AEB equals 94 and BEC equals 86. If we add the two of those together, it should equal 180. Check your work here. Assigning the relationships to the vertical angles of the angles we just assigned, we can solve for all four. Find the measure of angle 1, 2, and 3. Take a minute to write down your work. Find the measures of these angles. Okay, angle 2 is 145 because these two are vertical angles. Angle 1 and angle 2 are a linear pair. 180 minus 145 equals 35. Angle 1 and angle 3 are vertical angles. Angle 3 is 35 degrees. Angle ABC and CB, I don't know, are a linear pair. That means the two of those add up to 180. Okay, 5x plus 30 plus 2x minus 4 equals 180. Solving for x, we get 22. Not the answer, the value that's placed in here in the x. Okay, we get ABC as 140, and the other answer is 40. Okay, complementary angles. It is a pair of angles two angles, that their sum is 90. Notice it is complementary. It completes it. It doesn't say nice things about it. So if these two, this little symbol, remember, equals a 90 degree, 65 and what equals 90, complementary angles are adjacent, 25. Good. Okay, adjacent angles. Adjacent angles have the same vertex and one side in common, OB, and then they have no interior points. They share no interior points, meaning there's no overlap. Okay, so angle AOB is green, BOC is blue. There isn't any overlap. We've got three different angles, AOB, BOA. We've got BOC, or COB, and we've got AOC, or COA. Okay, we can't say O, because there's a lot of angles here at O. Okay, RST and VST are not adjacent angles. Look at RST is green, VST is the pink, and there's that, oh, ugly overlap there. Not adjacent angles. Complementary angles. Complementary angles has a sum of 90. Doesn't mean they're adjacent. They're just complementary. Supplementary angles. Their sum is 180. Okay? These pair are supplementary and adjacent because they share the common side. Okay? These two are supplementary but not adjacent. They don't share a common ray. Okay, what do we know about this? Well, first of all, we know that the 5y to 50 minus 50 and the 4y minus 10 are vertical angles. What do we know about vertical angles? We know they're congruent, so let's set them equal to each other and solve for the y. Solving for the y, we can solve for the vertical angles. Now, angle 1. Angle 1 and this vertical angle we just solved for are a linear pair, so they need to be equal to 180. Angle 1 is 30 degrees. This tells us that they are complementary, which means the two of these equal 90. Set it up, solve for x. Don't forget to plug your x back in to solve for your angles. What do we know here? Well, we could start here. We could say these two are a linear pair, but we've got one equation now and two variables. Can't solve it. We could say that these two are a linear pair. Again, we've got two variables. Can't solve it. How about if we start here? We've got vertical angles are congruent. We solve for x, plug it in. We can get our angle to be 50. Then we can plug it into knowing that this is a linear pair. This guy is 130. We know that this angle is also 130. We can now solve for y. Okay, what do we have? We have vertical angles. See, it's formed by two V's. Two V's with their vertex touching. Vertical angles are congruent, solving for x. Okay, again, solve for x. What are these? Linear pair. Solve for x. Notice I didn't ask for the angle. I asked for x. Solve for x. What do you know about these? Right here, this little thing. They are complementary, meaning they equal 90. Solving for x. Okay, any questions, any problems, you're going to state them now.